Welcome back, everybody, to another deep dive. This time, we're taking a close look at NASA's latest press release about the Parker Solar Probe,
Oh,
which just completed its closest ever pass by the Sun. It happened on December 24th, 2024. Now get this. The probe hit a speed of 430,000 miles per hour.
wow.
I know, right? Faster than any human-made object. So let's unpack this incredible feat and see what it means for our understanding of the Sun.
You know, what's really remarkable about this. The Parker Solar Probe has actually done something we once thought was impossible. It touched a star.
It's a monumental achievement for sure, especially when you consider that scientists have been dreaming of this moment since 1958.
Yeah, it really shows what decades of research and technological advancements can lead to. To put it in perspective, the probe came within just 3.8 million miles of the sun's surface. Now, I know that might sound like a lot,
It does.
but in the grand scheme of space, it's unbelievably close.
So how can we wrap our heads around that distance? I mean, 3.8 million miles still seems pretty far out.
Okay, imagine this. You shrink the entire solar system down to the size of a football field. The sun's at one end zone, and Earth's way down at the other. Where would the Parker Solar Probe be?
I don't know, somewhere in the middle.
Nope, try 4 yards away from the sun.
Wow, that's insane. That's like right on the edge of the end zone.
Yeah.
Okay, so another thing that always blows my mind. How can any spacecraft survive those insane temperatures near the sun? We're talking about the sun's corona, right? Its outer atmosphere. Temperatures there can get over 1,000,000 degrees Fahrenheit.
Right, well, that's where the engineering brilliance behind this mission really comes in. The Parker Solar Probe has this special heat shield. It's made of this super advanced carbon foam material. This shield can take the heat up to 2,600 degrees Fahrenheit. That's hot enough to melt steel.
Seriously.
Yeah, and all the while, it keeps those sensitive instruments tucked away behind it at room temperature.
So it's like giving the spacecraft a super-powered oven mitt, basically. I guess without that protection, it couldn't do its job right.
Absolutely. That shield lets the Parker Solar Probe gather data from one of the most extreme environments imaginable. I mean, we're talking about flying right through the sun's corona. The measurements it's collecting could totally change our understanding of the sun.
So what kind of data are we talking about here? What mysteries is this little probe helping us solve?
Well, for starters, it's helping us figure out how the corona gets so incredibly hot. It's further from the sun's core. You'd think it would be cooler, right? But it's not. We're also learning more about where the solar wind comes from. You know, that constant stream of charged particles flowing out from the sun.
Oh yeah, the solar wind. It's what causes those amazing auroras we see near Earth's poles, right?
That's right.
So what else is the probe telling us about the solar wind?
Well, another thing we're investigating is how those energetic particles in the corona get accelerated to such incredible speeds. They can reach half the speed of light sometimes.
Half the speed of light. That's mind-blowing.
It really is. This latest close pass is giving us a ton of data on how the solar wind gets sped up near the sun's surface. It's something we've never been able to study this closely before.
So this close pass is pushing the limits of what we know about the sun. Now, this isn't the Parker Solar Probe's first rodeo around the sun, right?
That's right.
Can you tell me a little bit about its journey so far?
Sure. Since it launched back in 2018, it's been on this carefully planned trajectory. It uses what we call gravity assists from Venus to kind of fine-tune its orbit around the sun.
Gravity assists. You might need to break that down a bit for our listeners.
Oh, of course. Basically, a gravity assist uses a planet's gravitational pull to change the speed and direction of a spacecraft. You can think of it like a cosmic slingshot, pulling the probe closer and closer to the sun with each pass.
That's amazing. So this strategic maneuvering, that's allowed the probe to collect data from several passes already. What are some of the most exciting discoveries it's made so far?
Well, one of the most fascinating findings has to do with the corona's outer boundary. It's surprisingly wrinkled.
Wrinkled.
Yeah. We used to think it was a smooth sphere, but it turns out it's full of spikes and valleys. That was a real surprise. And then there's the origin of switchbacks.
Hold on, what are switchbacks?
Imagine the solar wind suddenly making these sharp turns, zigzagging its way out.
Like it's changing its mind which way to go.
Exactly. We knew these switchbacks existed, but the Parker Solar Probe actually traced them back to the sun's visible surface. So now we have clues about how the solar wind gets its shape as it leaves the sun.
Wow, so with every pass, we're getting a clearer picture of how incredibly complex and dynamic the sun really is. The scientists must be thrilled with all this data.
Oh, absolutely. This latest close pass is like a scientific goldmine.
I bet.
Yeah, I mean, we're talking about a monumental amount of data here. This new information is going to help us understand the sun's atmosphere like never before, especially how the solar wind speeds up close to the sun's surface. It's a region we've never been able to study in such detail.
And it's not just about knowledge for knowledge's sake, right? This stuff has real implications for us here on Earth.
Absolutely. You got to remember the sun is like this powerful engine driving our entire solar system. And the solar wind, with all those charged particles constantly streaming out, it can really mess with things here on Earth.
Yeah, like solar storms, right? I've heard they can disrupt satellites and communication systems.
Exactly. The solar wind interacts with Earth's magnetic field, causing all sorts of things, from the beautiful auroras to those disruptive geomagnetic storms.
So the better we understand the solar wind, the better we can predict and protect ourselves from those events.
Right. And as our technology gets more and more advanced, understanding space weather becomes even more crucial.
Pretty wild to think about. Our satellites, power grids, communication systems, they're all vulnerable to what the sun's doing.
Yeah, it's like the Parker Solar Probe is this tiny little sentinel, braving the heat to warn us about our powerful neighbor.
I like that, a tiny sentinel. Now, you mentioned earlier that the probe also does flybys of Venus. What's it learned about Venus?
Well, it's observed how these giant solar explosions, called coronal mass ejections, act like giant vacuum cleaners sweeping up dust as they travel through space.
Like a cosmic dust buster.
Pretty much. And it's made some interesting discoveries about solar energetic particles, too. You know, those high-energy particles that can be hazardous to astronauts and spacecraft.
So it's helping to make future space exploration safer.
Yeah, you could say that. Oh, and during its Venus flybys, it recorded the planet's natural radio emissions and even got the first complete image of Venus's orbital dust ring.
Wow, that's amazing. So this latest close pass must generate a ton of data. When do we get to see it?
Well, right now the probe's in a position where it can't send back large amounts of data, but soon it'll be in a better spot to transmit all that precious information back to Earth. Can you imagine the excitement among scientists getting all that fresh data straight from a region we've never explored before?
Oh yeah, it must be like Christmas morning for them. And this isn't the end of the mission, is it? The Parker Solar Probe has more close encounters planned, right?
Absolutely. This is just the beginning. The next two close passes are scheduled for March 22nd and June 19th of 2025.
So this cosmic dance continues. The probe getting closer and closer to the sun, unlocking more of its secrets with every pass.
It really is a testament to human ingenuity, our curiosity and drive to understand our place in the universe.
What's been the biggest takeaway for you from all this? What stood out the most?
I think for me, it's just the sheer audacity of it all. Like, we sent a spacecraft to the most extreme environment we know of, to a place with unimaginable temperatures, and we did it to answer these fundamental questions about how stars work. It's incredible.
It really shows how much we still don't know about the universe, even about our own sun, which we kind of take for granted. But it's a reminder. It's this complex and dynamic object that plays a huge role in our existence.
Yeah, and as the Parker Solar Probe keeps getting closer, it's going to keep uncovering more surprises. It's challenging everything we thought we knew about stars.
It feels like we're entering this new era of solar exploration, where we can finally unlock the sun's secrets.
Yeah, and the implications are huge. I mean, this knowledge could help us predict and protect ourselves from space weather, understand how stars form and evolve, even shed light on the search for life beyond Earth.
It's a pretty amazing time to be following space exploration. As we wrap up this deep dive, I'm left with this sense of awe, knowing that this little probe, built by humans, is out there, braving the fury of the sun,
Yeah.
to bring us back knowledge that could change the world.
Yeah, and it's just incredible how they did it, using the gravity of Venus to slingshot the probe closer to the sun. It's a testament to our understanding of, like, celestial mechanics, our ability to use the laws of physics to achieve these extraordinary things.
It's inspiring, for sure. It shows that even with these immense challenges, human ingenuity and determination can prevail. Who knows what other mysteries the Parker Solar Probe will solve in its future close encounters? It seems like this journey of discovery is just getting started.
Yeah, I can't wait to see what new insights this latest close pass will reveal, what new questions it'll raise, what new paths of exploration it will open up. The universe is full of wonders, and we're just getting started.
Absolutely. Well, that's all the time we have for today's deep dive. But to our listeners, we leave you with this. As we learn more about the sun's power and complexity, what other mysteries might the Parker Solar Probe uncover in the future? What new knowledge is waiting for us out there? Keep looking up, keep exploring. and keep asking questions. The universe is full of wonders, just waiting to be discovered.